Okay, hello everyone, and welcome to our very special edition of Office Hours this week. We're excited to be joined by Infinix's Chief Data Scientist, Natalia Arzeno-Gonzalez, who drives and executes our AI and machine learning strategy. I am Akarsh Sethi. I am Senior Product Manager for Patient Access, and I have the privilege of working very closely with Natalia. So, Natalia, are you ready?
I'm ready. This is a topic I'm excited about.
Great, likewise. So, there's been so much conversation about AI and machine learning in the past few years. And then I think the whole burgeoning of ChatGPT has just taken this to a whole another level, with people learning more about natural language processing and really generative AI specifically, right? So can you talk to us a little bit about what even is generative AI, and then what are the types of problems that generative AI is looking to solve?
Yeah, so ChatGPT is definitely very prevalent nowadays, and it has been for all of this year. But if we go back to the concept of generative AI is just different kinds of models that are generating some sort of content. So we've seen that in the case of ChatGPT with text, but there's other kinds of generative AI models, maybe for art or music, or different types of data. Now we'll stick with text generation, I think, for considering use cases with healthcare RCM. So for text, probably the best known generative AI types of models are the large language models. We'll just call these LLMs, it's easier to say. And the ChatGPT and the different GPT models fall into this type of model. Now, LLMs will take an input, and this input is commonly known as a prompt. Now, the input may be, for example, a question that's being asked. And then the answer returned by the model is based on the different patterns and knowledge that it has gained from the data used to train that model. Now, it matters how an LLM is trained. So an LLM basically is trained to predict the probability distribution of the next word, just given some previous words or given some context. So based on all of the text that it has seen during training, it can then return a result to a question that is both likely and coherent. Now, it's important to key in on the phrase probability, because there is some randomness in the answers provided by an LLM. So we may have multiple calls with the same prompt, with the same input, that return variations of the answer. It's not exactly the same each time. So LLMs, some of them especially, are quite impressive at performing certain tasks. You ask what kind of problems. So we've seen these being very successful at summarizing or maybe extracting key points from some text, creating content given some very specific guidance, very specific instructions, maybe translating text to a different language, or just modifying text to target different audiences. So I could take a very technical talk, pass it to ChatGPT, and ask it to make it more accessible to a wider audience. I didn't do that for today. But these general tasks also exist in healthcare and the revenue cycle specifically within healthcare, as long as we consider the domain knowledge of healthcare. So if we think of like healthcare or RCM specific tasks where LLMs might be useful, or these problems could benefit from LLMs, either now or in the future, potentially, just given how the technology is constantly advancing, we can look at explaining medical concepts or benefits to patients. And that goes into rephrasing text to different audiences, to target different audiences. LLMs could be used to analyze payer guidelines or summarize very lengthy clinical notes, extracting key points from those notes, document classification, which could really speed up some of the back office operations. And also we could use LLMs just to add some structure to free text data. So anytime that we have notes typed in, LLMs could help us be able to analyze these at a higher scale than someone just looking at these and manually annotating them.
Okay, sounds good, Natalia. So I see a lot of people talk about generative AI, and I'm sure, that helps them understand what it is. Can you also talk to us just a little bit about what are the other types of AI as opposed to generative AI, right? So that people have some context.
Yeah, so we're saying generative AI is creating some sort of content, some sort of answer based on the inputs, but we can think of just more traditional machine learning models where we're taking tabular data or perhaps time series data and making some sort of predictions, right? That is a different kind of model that could be used. And then we have more traditional NLP models as well. Now, LLMs do fall in that NLP domain. A lot of them do take advantage of what's known as a transformer architecture in order to be able to handle large amounts of text at once. And there's different advantages to having that sort of architecture. We won't go into that right now, but there's other types of models that are more, or general use cases where LLMs or generative AI may be used, but not necessarily, such as we might be looking at information retrieval or some sort of classification task, where we're looking at one specific output. So we're not looking at a chatbot. We're not looking at just creating something new. We want to maybe classify or predict or group. And there have been people using and experimenting with LLMs for these different kinds of use cases, but machine learning has been around for a long time. And even though large language models have been around for some years now, we've really just seen it blow up in the last couple of years. And so people are now still getting to know what these models are capable of and for what kind of use cases could they be proved to be really beneficial.
Okay, got it. So then let's focus back on LLMs. I feel like people just want to use LLMs everywhere all the time now since the inception of ChatGPT. But I want to talk a little bit about, how effective or accurate LLMs are. So can you talk to us a little bit about what are the factors that impact the output or the results of large language models, and how do you judge that?
Mm-hmm. Yeah, so that is a good question and a good point. LLMs are just something new that has some amazing results in certain use cases in certain fields. And so it is important to understand what does affect the output of these models. So there's several things that affect the model, but just based on the explanation of how LLMs work, right? We can think of the training process. It's often known as pre-training when you're talking about training from scratch. So the pre-training process, both what kind of strategies were used and what kind of data was used for pre-training. So both of these just require a lot of...
Natalia, I'm sorry, what is training?
Yeah, so training is what gives the model its knowledge. So we pass some data, we use some math, and then it's able to, it is in the essence in the back, all math with some like randomness in it, but it's the way that the model learns. So when we talk about learning from data, that is achieved through the training process. And so I mentioned training strategies. A little bit ago, I mentioned that we're looking at predicting what the next word might be in order to create a sentence that makes sense. It isn't as simple as just that, though. There are many objectives that are being used for training these LLMs and different kinds of strategies, like where the data is sourced from matters, how the data is formatted, whether humans are looking at the answers and providing some feedback. So these all go into training strategies and what training data is used. Now, something like ChatGPT is trained on just data from different domains, general internet data, but they were careful about what sites and what sources they use for their data as well. We don't want to train a model with just everything from the internet, because then that might create some inaccuracies. The data curation becomes more difficult. So we are looking at trustworthy data sources for creating these models or for training them. But if we look at a general text data and we're saying, okay, we want to now apply this model to clinical notes. Clinical notes have a very specific way of being phrased. And it's different from other kinds of medical texts. So if we're looking at data using our model trained with maybe biomedical publication data, such as PubMed articles, which do exist, those will have a lot of the terms used in the clinical notes. So they'll have diseases, they'll have symptoms, they'll have procedures, and they'll have different kinds of medical terms in it. But clinical notes themselves will have a lot of abbreviations. They often have incorrect grammar and typos. And just the way that the words are phrased is very specific. So if we want a model that will work on clinical notes, then it has been shown, just different studies have shown, that a model that is trained using this kind of data, and again, train is what makes the model learn. For LLMs, there's two kinds of training. We have pre-training, which is training from scratch, or fine-tuning, which is taking a model that already exists and kind of training it further on very specific data, maybe on your own proprietary data set. So doing this training from scratch or fine-tuning from the clinical notes does prove quite beneficial for handling clinical notes themselves. Now, generating this type of data set is not trivial, and there are quite a few computational costs associated with training from scratch. So, and then coming up with new training strategies, probably not necessary for most companies, but that is, deciding on a training strategy will affect the output of the LLM as well. But that's not the only way to affect the output itself, right? So we can look at training strategies and input data, but we can, here this would be a good place to maybe talk about prompting. So when you type in a question into ChatGPT, that is writing a prompt. And your answer obviously will be largely dependent on what that question is. Now you can prompt the LLM multiple times and get slightly different results. Or you can prompt it with slightly different wording and then get a vastly different result. So then we go into prompt engineering. It's designing the best question, the best input, the best prompt in order to get the desired output. And this prompt may include instructions about the task to complete, such as I want my answer to be in bullet points, or I want my answer to be in a table. You can include information about what persona the model should take. So acting as some sort of specialist, or how the data should be analyzed. I want you to first look at this in the text and then complete this. If this happens, you can write a series of instructions. So just to make this a bit more concrete, like let's say that we're prompting saying, given the following denial letter from a payer, create a numbered list of the reasons for denial, as well as the corresponding guideline sections referenced in the letter. And that would be written, and then you would pass some text specifying that this is the denial letter. Then you would get an answer. So you would probably get a list of the denial reasons. LLMs are quite good at doing that kind of task. You can go further and tell it, acting as a prior authorization specialist, perform this task. And then that helps guide the LLM towards a more domain-specific answer as well. Now, this would be just kind of setting a set of instructions and then describing the input that you're passing. What kind of text is it in order to get a good answer? But there's a lot of different kinds of prompting. So there's what's known as chain of thought prompting, where you ask the LLM via instructions to provide the steps taken that lead to the answer, or to provide a rationale for the answer. And then there's multiple prompting, where you get an answer and then you ask a follow-up question. And then maybe you're asking it to refine its answer to get to a more accurate result. So in this case, we're kind of, we have to chain our prompts. So we're passing a bigger and bigger prompt each time, at least in the back end. So, and data, pre-training strategies, prompting. Now, one way to really guide the model so that it's not just looking at general information or general text that it was trained with, especially if you have some sort of database with information or with documents that you want to get an answer from those documents, or if you know that the answer to your question is in some sort of book or page or like any sort of reference text, then we can use retrieval augmentation, where we're retrieving that additional information, that additional document or section of text, and then passing that in the prompt itself. This is called in-context learning. Or sorry, this is the retrieval augmentation. And then in addition to that, we can do in-context learning, where we're providing examples of questions and then answers for a similar use case. So we're saying, okay, well, this is my denial that was provided by the payer. These were the denial reasons. Now, given this next denial, what would be the denial reasons in this format again? So there's a lot of different ways to experiment with prompting and with what context is passed to the prompt in order to really guide your result to the most accurate answer possible.
Got it, Natalia. So I think you touched, on, of course, the power of generative AI, but how to actually utilize it to the best of its potential for specific use cases and domains, right? So one such use case and domain is in healthcare revenue cycle management. And that's what a lot of our audience, is concerned with here. So can we talk about specific use cases in revenue cycle management within healthcare where this technology can be applicable?
Mm-hmm. Yes, there's many use cases that we can consider within healthcare RCM. Before necessarily going into what use cases they would be beneficial for, it would be good to always evaluate if there is an existing solution that's maybe simpler that could be used. So LLMs are capable of many things. They can do math, they can perform data transformations. But if I just have a tabular data set and I want to predict something based on that data, I'm not going to use an LLM for it. I'm going to use some more traditional machine learning model for it. And then we also have to look at, so that's looking at the input. We can look at whether simpler solutions also exist. So LLM, right, large language model. These are very big models with high costs to running, both on the training side and for the computational requirements or API calls. So if a simpler model exists and it serves our use case, then we might want to go with that. So if we're looking at writing a letter for a prior authorization request, and this letter just requires filling in some blanks in a template, we don't need an LLM to make the verbiage nicer. We can just take a template, fill in the blanks, and get the same result or a very similar result. However, there are many use cases in revenue cycle management where LLMs may be beneficial. Now, one thing to really keep in mind is that we need to be able to resolve some of the risks to the LLM. So I can talk about those along with some of these use cases as well. One big one would be just making sure that we're not leaking PHI. Okay, so that at the moment is one of the biggest risks with LLMs and using it with healthcare data. So on the patient access side, and we can just kind of go through the revenue cycle, just starting before an appointment. On the patient access side, we can leverage LLMs to maybe help patients understand what procedures is being recommended, or rephrasing the EOB, the explanation of benefits documents, and maybe even having some sort of chatbots that are leveraging these LLMs in order to help patients understand better what's about to happen and what their responsibilities are financially. Just answer any questions they might have. If we're looking at receiving documents, so perhaps specialists are receiving many referral documents or different types of documents. So we're getting insurance forms. If we consider multimodal LLMs, multimodal meaning that we have more than one kind of data. So we might have images and text. Then these could be very helpful in offloading some of the administrative work, especially for document classification and referral management. Now, using some LLMs, such as ChatGPT, by passing images to them is a newer capability for most people. So the accuracy of the data extraction from these referral documents would still need to be validated. Now, if we move on to prior authorization, then we can consider some more complex use cases that would be good candidates for future use of LLMs. And here it's important to know that these are future, because there are some current limitations to the LLMs that might make these not be a great candidate for implementation right now. But we could potentially in the future use LLMs to determine whether a patient meets medical necessity criteria. We have access to the patient's history and clinical notes, the payer guidelines, the procedure that's being recommended. Can the LLM take all of this information and output some sort of, and output whether the patient meets the criteria or what's missing from the criteria? Now, this is a complex process, a complex decision that needs to be made. So the LLM would need to understand the information in the clinical as well as the requirements in the guidelines, right? So there's an information retrieval step where we need to understand patient symptoms, diagnoses, prior treatments, prior tests that have been done, as well as potentially the results of those tests. And then also understand whether these requirements match the requirements from the guidelines. And so it isn't a use case where you would just pass everything to the LLM and just ask, does it meet medical necessity criteria? Like that level of complexity is not quite there yet. There are ways to start working around it by multiple prompts or chaining multiple prompts, but it is still a limitation. And we're hoping as technology continues to improve, then these types of complex decisions will be easier to implement. And LLMs could be a good candidate to determine if medical necessity criteria would be met. Now, one good use case for LLMs at the moment would just be for structuring text and then having that text be used for later analyses. So we can look at extracting denial reasons from different letters, or just or structuring the notes written by some prior authorization specialists in order to then perform later analyses on these types of data. On the post-care side, coding is something that requires text, and it sounds like an excellent use case for LLMs. But we have a lot of the similar limitations that we do for medical necessity criteria on the prior auth side. And there are just too many limitations, right, at the moment to implement this with high accuracy, because coding especially would require understanding of the current coding guidelines, the current code sets, and the rules for what is billable, what's not, what can be built together, what level of evidence do you need for different types of coding, and then that accurate extraction of the codable diagnoses and procedures. Now, current limitations that kind of prevent us from doing this right now would be risks to PHI, hallucinations, the complexity of the decision making, and then just updates to the guidelines. So we can't just have an LLM trained on data from 2 years ago or 3 years ago and ask it to check for the coding guidelines and use those for a clinical note that was created today. So we would need to kind of pass more of this context, more of this information in order for the LLM to have the latest information in order to make the decision or in order to generate the answer. And then all of this, even though it might sound, okay, well, I just grabbed this and then it's more straightforward, let me pass it. But as we increase the prompt size, then it becomes more challenging to answer for the LLM to answer the questions with high accuracy as well. Now, So we're past coding and past billing. We can also look at LLMs in denial management. So can LLMs be used to take denial specialists' notes and then use those to generate denial appeal letters? Like that could be a potential use case for LLMs. We can also use LLMs in order to perform denial analyses. So, and then steps taken to resolve a denial. So we can use LLMs to structure these free notes recorded while working the claim, get the steps that lead to denial resolution, and then use these steps as a new data source in order to create models that might predict what is the next best action in order to resolve the denial. Now, a few points to look out for when we're deciding if an LLM may benefit an RCM use case would be to just understand the complexity of the task and the nature of the data or the text involved. We also need to assess the level of accuracy needed and the consequences and cost of such an inaccurate response. And then also we need to consider the size of the context that's necessary to answer the question that's being asked to be able to create a response to the prompt. Now, most use cases using LLMs will require extensive experimentation for prompt engineering in order to guide to the desired output. And wanting to use maybe domain agnostic data sets for very specific tasks, especially in the clinical domain, may require LLMs to be fine-tuned potentially, which would involve building a robust data set, inputs and outputs specific to the use case, which is also a non-trivial task. And always keeping in mind any costs associated with either fine-tuning, so again, just training a bigger model with your data, or running such large models should always be kept in mind when we're trying to decide if LLMs are the right tool for an RCM use case. And this is especially necessary when we're considering the amount of context, right, that is necessary in order to be able to even just answer a question, or if you're going to need multiple steps, multiple prompts in order to get the right result. So a lot of opportunity for sure in the RCM space, but we need to be careful with some of the limitations.
Okay, sounds good. So Daria, thank you for that. I think that was a pretty comprehensive overview of how LLMs can be used in RCM. Any closing thoughts, anything about how you see LLMs evolving? What do you see in the future of LLMs?
Mm-hmm. Yeah, so as before closing, I just want to address some of the limitations that might preclude us from using LLMs in RCM use cases. Privacy and compliance are really an important thing to look out for. So these are paramount in healthcare, and LLMs do have some risk in this space. So if we're working with LLMs hosted by third parties, we need to make sure that BAAs are in place, and that's not currently accessible for all companies hosting LLMs. Also, LLMs are subject to attacks that could lead to PHI leakage, so safeguards definitely need to be in place. As far as compliance goes, LLMs are also prone to what's known as hallucinations, so making up part of the answer. So you might be asking to extract diseases in a clinical note, and you may get some correct answers, but something else that was not mentioned there at all. Or perhaps if you're asking for specific codes, it might look correct, but once you look what the specific code means, you might find that it is just completely made up. So plausible yet inaccurate. So these are known as hallucinations. And even the ChatGPT page has a disclaimer saying that it might be producing inaccurate information. And then also we need to look out for variability in the answers of LLMs, especially if these models are being updated. They might provide drastically different results when called some weeks apart. Now, there's no doubt that LLMs can be beneficial in healthcare RCM. And as long as we are acknowledging the current limitations and evaluating the different strategies that could be leveraging LLMs, instead of just rushing to implement them, there is huge opportunity. So in the short term, we can look at LLMs for translating or rephrasing text, extracting key points from guidelines, structuring free notes. There's many use cases, and just being careful on the PHI side of things and ensuring security standards. Longer term, as the LLM performance continues to improve, especially for domain-specific tasks, now we can maybe leverage LLMs with higher confidence for information retrieval tasks, such as for coding, or maybe more complex decision-making, such as determining risk of denial due to lack of medical necessity or lack of meeting the medical necessity criteria. And so again, this is assuming that some of the limitations with privacy and compliance are solved, and always considering the cost. Now, improvement in the technology, as we've seen, it has already improved quite a bit. And it may end up yielding more accurate answers. We might be able to pass longer contexts, and also lead to the ability, or obtain the ability, to be able to complete complex tasks. So new developments in these technologies, such as LLMs, just open up new possibilities for maybe tasks that we thought weren't possibly doable with some machine learning model. But we just have to be mindful of understanding the technologies and their limitations, and then keeping that in mind, then we can embrace the new opportunities for maybe increased accessibility, precision, and efficiency in healthcare.
Okay, great. Thank you, Natalia. Are there any questions for Natalia from the audience? We will be taking some questions. So if anyone has a question, feel free to put that in the chat. Again, if there are follow-ups required, if you would like to have a chat with us, you can always reach out to Infinx. We're happy to talk more on this subject. Okay, we have people saying thank you, Natalia. No questions yet, though. Okay, sounds good. Then thank you, Natalia, for joining us today and providing us with some much needed education on generative AI and large language models. Thank you to the audience for attending. Hopefully, this was worth your time. And I'll see you next time. Thank you.
Yeah, thank you, Akash.